So I made a car out of something called an ESP32. It's this Wi-Fi enabled microcontroller, and I can programmed it over something called the Arduino IDE. Some of you might have heard of it. And so I took apart this.
What's your name?
Evan Alexei. So I took apart an RC car that I had lying around, and I mounted the ESP32 onto it and L298N motor driver onto it, and I made so now I can access it over Wi-Fi and control it, and I made an app for it so that I can drive it around, and it's actually hosting a Wi-Fi server right now that I can connect to. And I've connected to it, and I've connected to this IP, so now I can go forward, backward, turn, and everything. And that's pretty much all.
That's great.
This one, it's actually, I didn't program in Java. I just used something called the MIT App Inventor, very easy way for making apps.
Great, good job.
No, I'm the designated tap dancer tonight. My name's Dave. While Dillo's taking a minute to set up here, I work at a company called Savvy Oak. We do delivery robots as a service. And so one of the things that happens in the robots as a service business is every once in a while you get robots back and they need to be refurbed. And I have some motors with nice gearboxes, and they were destined to the dumpster. And so I rescued them. So here's the deal. I have 5 pairs of these guys. And the rules are, 1, I do not want to see these showing up on eBay. I want to see them coming back to the club in the form of a working robot. Rule number 2, to get a pair of these, you need to find Chris Mayer. Where's your, wave your hand. Where are you? Way back there. Okay. Give him a $20 bill donation to the Brew Robotics Club, and you can have a pair of motors. Bring them back in the form of a working robot. There you go.
Hi, I'm. Is this on?
Yep.
Hello? Okay, okay, all right. So first of all, I'm going to get some donations. Also get donations out of the way. I have a whole bunch of Turtlebot 2 follow casters. There's a bit of an interesting story as to how I came into these. Basically, the guys at Dabbit sent them to me because I kind of asked them if they would sell me a pair, because to get these from Eugen is like $10 and then $230 in shipping. So I hit them up at RoxCon, and it took them a couple months, and then I said, well, if you just have like 1 or 2, and I'll like pay you for them, and I'll even pay the shipping, because the shipping from Massachusetts is going to be cheaper than the shipping from Seoul. And right before Christmas, I got a box of them. There's probably like their entire stock. So if you need Turtlebot 2 casters, if like mine, yours have gotten some flat spots, and you don't want to pay $10 plus $230 in shipping, see me. I have more than I will ever possibly use in the life of my Turtlebot 2. So, but yeah, again, don't take these and sell them on eBay. I'm trusting you. Okay, so other thing. We have, let me just turn off this. So, I've been playing with the U-Arm from U-Factory. These are the same guys that did the U-Arm Metal, and they have another one coming out called the X-Arm, which is a proper like 60UF with no end effector gripper thing on the end of it, so you can attach them around. Apparently they're going way upscale with that. But this is kind of like their 3rd or 4th gen, and it's been pretty cool, and it's pretty hackable. And one thing I've been playing a lot with is flexible filament on my printer, and so I made a little grabber here they can actually pick up quite a bit. And right now, it just opens and closes. So I haven't had a chance to program it much beyond that, but I did just kind of want to show it off, so here we go. And it can actually pick up quite a few things. Yeah, please. So there we go.
Nice.
What?
Yay.
There we go. So I've actually been really surprised at what this will pick up. If you have something that will support it, like if you have an arm or something that can actually lift the payload, I've had it pick up a grapefruit, pomegranate, other small 3D printed robots. It would probably pick up and hold my phone, wait for it to open. Maybe not. Yeah.
How do you get that to fold in?
So here's the thing: is that let me just shut it off here while it's open. I'll tilt it up. But yeah, let me just disconnect that.
Is that considered a soft robot?
Yeah, this is considered a soft robot. So the kind of the magic here is that there is fish line out to each end, and it's tied around a servo horn. And then the servo horn, it twists and causes tension, and that makes the gripper close up.
Nice.
And then it releases the tension by going the other way, and it opens up. And so it does that. I use this fish line, and it's printed with TPU, which is kind of printable polyurethane. So it's a bit tougher and a bit stiffer than NinjaFlex, than the PPE that I made the robot tires out of. That I think I showed that at the October or November meeting.
Because the one Alan got in trouble for, right?
Yeah. Yeah. So that's kind of it. And I'm gonna. Here's the other thing. What goes on the end of this is I have a little mount here that I printed for a Raspberry Pi camera. So this fits underneath that, and it covers up the servo, and it also provides a little stand to put a camera on, so now the arm can see. And we've got some expansion ports here. There's a SPI port right there on the arm. And there's a what's running this is one of these. It's an Arduino Mega 18 Mega 2560 on the inside there. So all in all, pretty cool. Oh, and there's a ROS driver for it, which I actually wrote. So yeah, that's pretty much about it. Thank you.
So this is like the story of the three bears, only it's the three biped robots. First biped robot, and Chris had one, was my original one from 2005. It was a foot tall, and it wasn't tall enough. The bear was much too small, so I built Karen, and Watson and Karen, and that robot was much too big. So the new thing is I'm going to build one that's kind of in the middle.
Right.
Just right.
Goldilocks robot.
So yeah, the Goldilocks robot. That's a great name for it. So I started out buying these really big 60 kilograms per centimeter servos from China. They're cheap and they're really powerful, but I had no way to mount them on anything. So I took my milling machine out and I made this little thing holder, and that was a mistake because it took a long time. And what do I do with it now that it's on there? I got to put a horn on it and a gear and a this and a that and everything. It just wasn't very conducive. The other problem is it's standard RC PWM position control open loop. You turn the robot on, and if it's in a funny position and you try to move to something else, you break everything, which was the problem with Watson, which is why now Karen, and it's why it's never working, because I keep breaking the gears inside. So I'm not doing anything open loop anymore. So what I decided to do was to turn this servo into something less primitive. So I used Fusion 360, and which is great. If anyone wants to learn CAD stuff, Fusion 360 is the way to go. And I did that in about a day. And then at work we have a $50,000 3D printer, and I just sent them the STL file, and we now have this, which I don't know if I can get this on the camera.
Just put it in front of the screen, computer screen.
Right there.
No, I mean,
In front of.
yeah, there you go.
There. Oh, there. I thought you took the camera. All right. So what you can see now is that we've gone from this, which just has nothing on the back side, to this that has a bearing on it, and there's where the horn goes. And so now I'm working on a bracket that can actually just do this, which is the way most robot servos work. Additionally, inside here is a magnetic encoder and a converter that will take serial in, pass the position back to the microprocessor through a serial port, and give you position feedback and control of this servo. And so basically the idea here is to take an inexpensive servo and turn it into something that has position control and a decent mounting system that most don't have. And so this is the start, and that's pretty much it. So the only other thing is, if I can get this up here quick enough. This is the first part of this is going to be the bracket. So the bracket will fit on here. And I'm just learning how to turn things in 3D space. So I haven't actually gotten there all the way. And it will just mount right on here. And you know, as they say, Bob's your uncle and everything. And actually that holds two servos. So you don't have to screw plates together. Steven.
What CAD application are you using?
This is Fusion 360.
Okay, Fusion 360.
Yeah, it's really great. The best thing about Fusion 360, in my opinion, is Lars. And so when you go on YouTube and you want to see how to do something, you say, Fusion 360, how do I extrude something? And Lars comes on and he gives you a 40-minute lecture on how to do it. And there must be 200 lessons. So you could spend your life learning Fusion 360, but you don't need to spend your life doing it. So he just makes it real easy.
I totally endorse that. It's an amazing program, and right now, for some time, it's going to be free.
It's currently free.
It is just amazing.
Unless you use it to make money, and you have to make over $100,000 on the product that you use. And my opinion is, if you're making $100,000 on a robotic project, pay them the $20, $30 a month, because everyone deserves, to make a living. Mr. Mayor.
If you'd like to show pictures of Karen, I just sent you an email with a link that you can click and pop it up right now.
A link.
In your email.
I don't have a web access here. I'm at Google. I mean, maybe I do, but it said I didn't.
Never mind that.
Never mind. Yeah, hopefully I'll be bringing Karen in at some point soon.
Does that have the restrictions that
No restrictions.
The
software has no restrictions. No restrictions. Because there was somebody who actually was paying for it and said, but I'm paying for it, can I get my money back? And the guy said, no, but you can have it for free after your 1-year subscription's up. So there are no restrictions on the software. You can do whatever you want. And it's got great simulators and everything in it. It's really great.
It's incredible.
It is an incredible piece of software.
Just amazing.
Yeah, just amazing.
I don't even work there. Okay?
No.
I know.
And it's the first time I've ever endorsed an Autodesk product. But yeah. Thank you very much.
Robots to show.